All right. So, hello guys. Hi. As I said, I will be helping you with designing databases, right? Which is, I feel like many people are failing in that. Many young people and even like with experiences don't know how to design a database. So today, first thing to understand today is that I'm recording this at home. So you might hear some background noises, some people screaming, talking, bells ringing, vehicles going outside. So ignore all that and let's just get into it. We'll be focusing mainly on these four things, right? That's the normalization and data many-to-many relationships, weak and strong entities, which many people don't know about. Okay, this is important in designing a database. Then how this S from solid principles, that is the single responsibility principle, can be used in database as well. So 1NF is simply, you can get all this information on any website. Okay, it's very simple. 1NF simply says that no record in a table should be duplicate. Okay, that all the columns must be unique and all the columns must have only one value. Okay, they cannot have a comma separated values like this. Okay, that's what 1NF says. 2NF says that every record must depend on a primary key, even if it is a composite key. So if I say there is a SID, that is the student ID, we have a course ID, and we have student name. Now here you can see these two are keys. Let's say these two are foreign keys, they make a composite key for this particular table, right? But the student name does not depend on the course ID, right? The course ID does not have anything to do with the student name. It only depends on the student ID. That means this table violates 2NF form. So for that we must create two tables. Actually there should be an SID and CID in one, and the association of SID with student name. Okay, that's 2NF. 3NF, with including 2NF, that every row should depend on a primary key. It says there should not be any transitive dependency, which is simply an example always has been taken for this is student ID again, let's say, then course ID, we have a department and a department head. Okay, so again here you can see that a department head will always be dependent on the department, right? If there is a department, then only there's a head, right? There's only an HOD if there is something to lead, right? So this is dependent on this, and we know from this whole thing, right, this department is dependent on either of these two things right now, because this is, let's say these two are foreign keys here, and this is not a key, this is not a key. Okay, then that means you can see through transitivity, you can see the department head is related to student ID. How it goes is like this: department and the department head. So this violates the 3NF form. For again for this we need two tables to define it. We have SID, we have CID, we have the department, and the other one where we have a department and the department head as an association between these two, just how here we were with the SID and SID from other tables. So that's how normalization works. Okay, keep that in mind that these rules have the only reason for normalization is to achieve better databases, you can say. Let me increase the size of my eraser so it is done quickly. Okay, so what happens, normalization is only used for reducing your size, reducing the redundancy in the database, right? No extra records, that's all. Okay, no extra records. Then it's used for, you can say, when you have a normalized database, it will be good to do search queries, right? Or reads, that's one and the same actually. And writes or updates, that's one and the same again, right? Or deletes as well. It's easier to do these things. And with the rules in place of normalization, after normalization, with the rules in place, an association of IDs to IDs, right, with different tables, when this is affected, we can define a rules. We have cascading rules that if this is deleted, then this is deleted. If this is updated, then this is also updated. Something like that we can define through triggers, also through different database rules also. Okay, so that's all for actually normalization. There's not much other than that for normalization. Now, how it makes many to many relation, because this will lead to this. Okay, but before that, let's do weak and strong entity first, because these two concepts are important. Okay, now a strong entity, let's say, is independent. Anything that does not depend on any other entity's reason of existence, for existence of its own, is a strong entity. Okay, for example, let's say, now remember this, the area that we are working on is very important in this. Okay, let's say we are only working on a school level thing, school level database. So we know, so the highest authority over there is the principal or the school board or trustees, something like that. Okay, now those don't need, those are strong entities in that. Now if you extend this, let's say a school is part of a state, right? A school is part of a board, a school is part of a country, a place, the area, then the strong entity would be the area and all and all. You can always go higher till god maybe. Okay, so in that way you can make it very high if you want, but the thing is like you might not need to all the time. Okay, so a strong entity, any independent entity is a strong entity. Okay, and any dependent entity is a weak entity. You can even think of your let's say your relations, right, where one is dominant, one is submissive. You can even think of your parents and children, where parents are different, kids are small, parents have to make the decision for the kids. Dominant people lead the submissive people, right? Leaders lead the followers, right? So leader is the strong entity and weak entity are the followers in that way. So in the same way, strong entities and weak entities are important to make relations. How? I'll tell you. Let's say, let's take an example of a bank. All right. Now let's say, not of a bank. Let's say I want to take example um, offers to of a course only. Okay. Let's say there's a course, and we have the course ID. We have the course name here. Okay. There's one course called physics, and in the school we are saying that only the people, there are people over here, right, who are teaching, right? So we have teachers, and we have ID of the teachers, we have the name of the teachers. Now I want to show a relation between these two. Let's say I make a rule that I the relation should be only 1 to 1. Only one course should have only one teacher, right? Not more than one teacher. And one teacher should only teach one course, right? A physics teacher cannot English course and stuff like that. That's wrong. Okay. Now when we do that, what happens is this. Now who is dependent of who? That's important now. Now teacher is only in existence because of the course, right? The teacher only will be existent because there's a course, and the course is here is independent because it's already defined that we have physics, we have chemistry, we have maths, we have Hindi, we have English. It's already defined, it's always defined. These are the most common things following. Biology as well, right? Computers as well, these are all defined. That means the course is the strong entity. In that way, whoever is the strong entity, because they lead the follower, they lead the weak entity, the course ID has to go here to know that okay, this teacher name teach is teaching physics. In that same way, if we have two over here, and they cannot be more than that, there only be one three, something like that. There cannot be duplicate rows again, right? In that way it will be done. In the same way, if you think of a many to many relation, let's say I'm allowing like you can have many teachers for a single course, because we want to teach multiple students, right? Multiple classes. then we can go like, okay, so this teacher 2 called teach 1 teaches physics too, then it's okay. Again, because course is strong, teachers are weak, that's how they work. Okay. Now the problem comes when you have a many to many relation. Okay, I'll just show you. Let me remove this. Not in school, obviously. Let's say there's a student table. Okay, student table, we have the student ID, we have the student name. Okay, and some extra field here, and then there's a course table now, right? Course table, and this will be the most common, one of the most common examples that you see out there. Okay, when you're practicing databases or something. Sorry about that. So I know that in a classroom, let's say if there are like 5 students, okay, and they are all studying physics also, chemistry also, and maths also. They have taken science in 10th, ninth and 10th, right? That's good. So they want to study PCM, all of them. Now the thing is here, the student itself is a strong entity, and course itself is also a strong entity. If you pass this ID over here, we'll have duplicate records. Now if I have like P course physics, right, and we passed something like this, something like a student ID over here, okay, with 1, then we'll have to have another record with this and 2, then this, because we know first normalization stops us from doing this, right? And in the same way, if we have course ID over here, it will stop us from doing that PCM like that for every records. So those are not normalized forms. What you do in that scenario? So what you do, whenever you see there are two strong entities which cannot be made weak, okay, ideally there always be one weak entity, okay, but if there cannot be, there are both strong entities and you have defined the relation, these two rules should be there always. Both are strong, both are strong entities, okay, and they should have defined a many to many relation in between them. Then only you do this. If one is weak and one is strong, then you can just pass along the message, right? Pass along the ID to the other. But since they're like this, we create a weak entity. Okay, we create a weak entity which will be used using the IDs of these two strong ones as foreign keys, or you can say a composite key like that. But know that this entity is weak. This entity here is dependent on the existence of a course and existence of a student. So the concept of this strong and weak entities are very important in designing any database, because you have to know where the IDs are being passed, where the foreign keys are being passed, where the primary keys are being passed, right? You have to know all that details. Otherwise, you cannot make a database. The problem not comes, let's say, many times, in many places you will see that the relation is already defined by itself, like there's a parent and a student, right? there's a parent there's a parent and a kid, so you know the defined entity. There is a teacher and a student, you know who is strong, right? Now you know here none of them, the both of them are strong, because teacher is an individual and independent, student is also individual and independent, right? Under the umbrella of the school, they are both independent, right? Now again, if you go into, let's say, departments and the teachers of that department, this is strong, this is weak, right? Then if you go into class and their teachers, this is strong and this is weak, right? In that same way, when you define a database, you need to know which entities are weak, which are strong, and how to make them work. And that's how, the same way, how we do through normalization, and through weak and strong entities, we can create many to many relations. Okay, many people, like 80%, I must tell you, 80% of the people I have interviewed do not know how to make a many-to-many relation. If I just give them this simple this thing, that we have a student table with ID, name and phone number, and we have a course table with ID, name and price, they cannot define a many-to-many relation between these two. Some of them just pass some of them just pass a course ID over here, and they are like, okay, we will do course name or ID like comma separated, but they don't realize that they are doing one NF wrong, right? They are violating that condition, and in that way they don't know how. So I know that they don't even know how normalization work in SQL or in database. Actually, SQL is different, right? So understanding these two three concepts will help you a lot. Now, the one thing that I'm making this video for actually is my realization how this thing over here, how it fits into database. Now we know how classes use or how structured languages use single responsibility principle, right? You have a class, let's say, called person, and we have the ID, name, address of the person. Okay, now let's say the person wants to make a bank account. What you will do? You will, and there's a, you will make a bank account class, right, which will have the account number, which will have the bank name or ID something, let's say, and any branch details, let's say, like that, right? And you will make that object here, bank account BA or AB, okay. And either it will be null if the bank account, there's no bank account, or it will have some value if there is a bank account, right? And this could even be an array or a list, right? So you know that a person can have many bank accounts. Now how this is how we would do in uh, in any kind of code, right, in any kind of language. Now understand how database goes through all these things. Now how database teaches us these things is like how database teaches us these things is simply like they will say that okay, we have one table which has all the things like person ID, name, address, and we have these fields as well, account number and bank details and all, and those are null at first, and later on we will add values to them. Or they will say, and they will come up with the problem that okay, these are null, every time we are reading these values, that's not also this thing, what do you say, if there is an SQL injection attack, that's not security wise, that's not good, these are sensitive information, right? Security and sensitivity of the data matters in that way. Now what if there are multiple bank accounts? They will say you will have account 1, account 2, and dot dot dot, something like that. And they will try to do that whole thing, like teach you like that. But imagine just doing this whole thing over in database. You say single responsibility principle, okay, that every table, right, every entity has to have its own responsibility, and maybe let's say open closed as well. It should be open for extension and closed for modifications. Now that will depend on your requirement analysis, obviously, what you have done, how much good requirement analysis you have done. But understand these two principles, they are so good that the person table will have its own responsibility to store its own values, nothing else. So it has its ID, its name, its address, let's say its phone number, and etc., any personal details, and that's all. We don't need any other bank details, we don't need any school details over here, we don't need all those extra things over here, because we don't care, right? Because we are following the single responsibility principle. We are not thinking of normalization over here, we are not thinking of a many to many relation. Normally normalization is going to get you over here, okay, to a normalized form where every table has their own responsibility. But if we know, if we directly apply this principle, it's going to work so well. Then again, let's say we have another table called bank account, which will be only needed to display the bank account details. Now if the id is if the person does not have a bank account, there's no row over here, there's no record over here. But if they create a new bank account, we have the account number, right? Then we have the bank id, let's say where it belongs to. We have the branch detail, ifsc code, something like that, right? And the relation between these two again is good, because a person is a strong independent entity, while a bank account is dependent, right? Is dependent on existence of a customer, that will be the person. So that means we know that the person id, that is the pid, let's say, goes over here, and there we add, that means we add a column over here called pid with the person id, and etc. And that's how the single responsibility principle can help you design the database as well. Isn't it simple? I don't want people to be like, okay, you can't know this. The thing is, there are many people out there who are working, let's say they call themselves full stack developers, and like that they can do back end also, front end also, but they don't know how to create a database, they don't know how to create the relation. I understand that many people are working with orms nowadays. Okay, many people are working with orms, and that makes their life easier. They follow the code first approach, and they can do these things. But when they do that, they are defining relations in their db contexts, or this is the terminology of entity framework actually. Okay, this is the terminology of the entity framework. But if there is any other terminology, there is, you always have to define the relations. Always. There will be tables, you have to define tables, you have to define classes for each table, even for the relations that you have, right? Even for the relations that you have, uh, the many to many things, that is, even for the independent and the weak, you need to create tables, you need to create classes for each of them. And still, if you cannot understand how these things work, how you are designing a database, that's kind of bad, bro. Okay, so I'm here to help you in that. This was my first lecture, you can say lecture only, because I'm just keep speaking. And know that nothing of this is pre-recorded, no voiceover. I'm talking to you as I draw over here. Okay, and thank you for listening to me. If you have had any value towards you, able to gain anything from this, know that you can do everything, everything is possible, any design is possible. If you follow these four concepts, anything is possible, any database you can design very easily. Later on, maybe if the you can shoot your comments, shoot your questions in the comments, you can shoot your problems in the comments, so I may understand what you want, what is, if there is any change that I want to do in my, I need to do in my teaching, we can do that. Any way I want to present myself, present the ways that I'm doing this, we can do, we can change that. And yeah, thank you. If you have any queries and questions, please comment below and let me know. I will be answering them as much as I can, as many as I can get, right? And if there is anything I have done wrong, you please go on and tell me. And okay, see you in the next one. In the next one, maybe we'll talk about notations, because one important thing in this database design are the er diagrams. There are something, two things actually, called class diagrams as well. You can depict using this also. Even though it's called class diagram, you can make entities, boxes, and just connect to each other using crow's foot or cardinalities like that. You can do that, but still we'll be focusing more on the entity framework, entity relation diagrams, right? Because the thing is, like, when you want, when you have a very big complex database, very big, with many small entities, right, everywhere, a diagram is the best way to depict your design. A diagram is the best way to depict your database. So next one, we'll do some notations. There are two notations that I follow. That is, uh, one is one that is I like very much, but it's a bit complex. because there's a lot of work to be done over there. I learned this in my FY actually. And the second that many people follow nowadays, many people in the industry follow. So we'll first look into this and then we'll look into this one. Okay. All right. Thanks for your time. And I suppose everyone have a good day. Thank you for listening to me so far. If you are here, that is. Thank you.